Hey guys, in this video I will be actually coding this bubble map from scratch and we'll be explaining things along the way. So without further ado, let me delete some of the things. And I'm gonna leave it to this part. I'm actually gonna leave a projection variable defined, the SVG defined obviously. No reason to recode that again. And I'm gonna keep this function defined. And for those of you who are completely new to this video, you didn't watch the last video because it was too long. Projection is something that we have to input to a D3.geopath to be able to map a GeoJSON's features to their desired SVG path positions. You'll get to see that in a second. I'll keep bringing these terms up. And this hopefully kind of makes sense. D3.q, and for each of the things that you defer, it is going to be a new argument here that you can access to, which is going to be data fetched from here. So that I don't care to explain more. You can take your time maybe to copy down these two links. Okay. So I'm gonna come in here, and from the last video, we learned that first of all we gotta draw the map and the bubble separately. So number one, draw the map. Now the map is actually not a picture. That is the biggest mistake that I first made. I thought it was a picture, so I was being really weird, thinking that why is there GeoJSON and mapping a different SVG path? Well, there are needs for that. People might be drawing really different maps, and SVG is always the best way to represent it, of course, because you know it's vector graphics. So map is different SVG paths, and let's look at our data geo object and circles for better intuition. So I'm gonna go in here and I'm gonna console.log geography data. Well, actually our GeoJSON object. I'm gonna log data geo, and I'm gonna do circle data. And it's gonna be circle data. Right? Refresh this. F12. So we can see that the first thing is an array of features, and each of these features would, the GeoJSON object is an array of features, and for each of these features, it seems like it consists of some sort of coordinates, and yeah, it's a feature that contains some attribute that we want to map to an SVG path. Sorry again if you watched the last video. I feel like not a lot of people will watch it, so I'm explaining a lot of things from scratch. Hopefully that helps you more. But let me get to it quick. I'm going to append a G container to my original SVG, and I'm going to make an empty selection. I'm going to select all the path which will be empty. I'm going to data to this, and it is data geo.features because if you look at the object, it's actually features and type. Well, of course we want to be mapping this features array, right? We're always mapping array in data. And then we're going to return enter. We're going to call enter, which right here is going to return 177 internals because there was 177 features. And I'm going to append an SVG path for each of them. And this is the part that we have to map around to get this function, this attribute D. Now, by the way, just in case you're confused, this D has nothing to do with this. This is each of the individual feature. We're getting access to the data binded to our. To make it more intuitive, I'm gonna say each feature, right? And this D is an SVG path value. We define this D to draw a path. So D3's API help us do this. Help us map the GeoJSON feature to an SVG path. So we're gonna make a new geopath from its API, and when we make that, it's gonna be. Well, I'm gonna name that path builder because kind of you put in a GeoJSON string and you build out the SVG map from it. I think that makes sense. When we define a path builder or geopath, it's geopath, and inside of here we want to put the projection. And this projection here is a projection that we define up here. The reason we have projections is because people want to look at maps different ways. the Mercator graph, which is the really general map, looks like this, right? Rectangular coordinates, 90 degrees, longitudes, latitudes, but some people might want to look at it this way, which is a little bit curved. So we define it with a specific projection because people, again, want to look at it different ways. And we can run these features through this geopath object in order to get the D attribute. So to do that, we're going to do return path builder each feature. Right? Oh, and actually it does work already. And we can look at the API to see why this works. It says D3.geopath is how we make a path object. So here we already made a path object. We just got to put in an object to be able to render it. And that object is a GeoJSON feature, right? Okay. Yeah, we're done with this already. I'm gonna make a few additions so that this is a little bit prettier in terms of UI. Gray, and I think, let me give it an opacity of 0.3. Okay, now we gotta draw the circles. This is a little bit bigger problem because we're gonna be messing with scales a lot. Let's look at the circle value to begin. And hopefully you still remember what it looks like. It looks like something like this. Where's the circle? The circle data is actually an array of 9,413 elements. It's crazy. And for each of these circle, we can see it has 4 attributes: home continent, home lat, home lawn, and end. I'm going to copy and paste that. And what these are really doing is we're going to be using this home continent to determine what color it is. We're going to be using the home lat and home lawn and running them through this projection to be able to pinpoint a new position for our circle that is aligned to the same thing as the map, right? This right here is Mercator Projection, so the circle it should be ran through Mercator Projection too. And then based on the end, we're going to render this circle big or small, and that's going to be run through a scale because some ends can get really big, but we only want our radius to be from 0 to 50. So first of all, let's not worry about the scale thing and append a G. Everything starts light, we append a G and see if it works. I don't know if the G is actually appended, but I better assume it is. We're going to make an empty selection again. And I'm going to bind not data geo but circle data, which is the second deferred link in our queue. So it's called circle data. And that is again the array of 9,413 elements. I'm going to call enter on it. And so this right here returns nodes, internals, and we can call append on internals to be able to draw those things. So I'm going to append a circle. In each circle we need an X, we need a Y, and we need a radius. For now I'm going to just return 10, but we got to define these X. So if we do 10 and 10, we just want something to be drawn for now. So there should be something at 10 and 10, perfect. But so return, we're going to run it through the projection. The way we do is projection each circle, and after you run a pair of X and Y through a projection, it returns an XY pair. So we got to access the first element to get the X, and same thing here. Oh. So it does not work. And let me figure out why. Maybe this is not one. Still doesn't work. Oh, I forgot. Each circle has attributes home lawn, and end. So we actually only want to be put it in an XY period. So it's home lat. I mean, each circle dots that, right? When we do, in case you have no idea what this didn't, oh god, you see it's good on the X. In case you're totally new to D3, if you do .append, now you can get each of the corresponding data that is from your data array. So each of these will be representing each of the element in the data array, just in case you're totally beginner. And by the way, if you're total beginner, I suggest you to be playing around with the update pattern more so than these APIs, because if you want to be building something really customizable, you probably want to know those better first. So as we can see here, we got the basic thing working, except radius is, of course, is a little bit weird, and we don't have our radius based on this n value, which we want to do. So let's do that. Now to do that, to create a scale, we have to define a domain and a range. Our domain in this case is the n, right? All of the n's are going to be the domain, and the range is going to be from 1 to 50, which is our desired radius range. So let's make here's how we make a scale var. How do I name this? How do I name this? I'd like to give these names really intuitive meanings. Okay, so instead of size, I think I'm gonna call it n to radius, right? And I'm gonna explain this in a second. And domain, oh, I don't have the domain say I'm gonna range, but its range is 1 to 50. How do we get the domain? How do we get this? How do we extract all of these n out and then find the minimum right here and the maximum? We can do this with D3.extent, n extent maybe, or n min and max literally. D3.extent, we're going to call it on the circle data, and return d dots n. Okay, so this scale right here, what it does is that if you input a new n value, it's going to map it into a range of 1 to 50. But of course, it's not going to be a linear mapping. With this scale square root, as our n increases, which it will frantically do, like some n's can go up to, I think it was like 2,500. We can log this in a second to find out. It can go up to 2,500. Now we don't want that to be 2,500 times bigger than a circle who has 1 radius, right? But we limit it, of course, but we don't want it to be scaling linearly. As the n increases, we want the range, the radius that it increases by gets smaller and smaller. And so we use this y equals the square root of x graph, right? That kind of represents a, you know, it's going fine at first, but then it kind of, okay. Now projection, n to radius. Okay, that did not look good. Let me see what I did wrong. Okay, it turned out that I have to put a plus sign in front of d.n because I want the d.n to be interpreted as a integer. Because in the default JSON object, everything is a string. So the 4 is a string, the 3 is a string. And I don't see why. Okay, because we're using domain to range and we're using scale square root, so those better to be the same object types. Yeah. So if we just put a plus right here, it should work. Now let's just play around with the attributes and everything should be good. Let's make the we're gonna do the colors in a second, but okay, let's make the color red for now. That looks bloody. Let's make it orange, and then dot attribute. I want this to be plus again, because yeah, return black. Also return on the white. Oh god, this is really ugly. Let's just do more. Let me see what else. Okay. And just doing what we did last time in the video. Okay, that's a bit nicer. That looks like a map that you can actually just straight up put into a production after you put some scale and information maybe. The last problem we have to tackle is to mess around with the colors. So we're going to do this. And remember, we are determining colors based on the home continent. And we could just do if Antarctica, return red, whatever. But the original programmer of this map decided to use a scale. That's definitely respectable. So it's going to be continent, then to color scale equals to D3.scale ordinal dot domain. The domain is going to be D3.map data, circle data, to D dot return the, what is the, I think it's called home continent, yeah, and dot key, so that's going to be the domain, and we're going to map that to, the range is going to be some D3 colors. It's also going to be an array, and I think it's called D3 dots. Yeah, this is called a. Now plus sign I think is called some like unary operator. I never did like functional programming. I mean, I never did like more advanced computer programming, so I'm not sure if that's what it does. But I'm sure there's a fancy way in like the 32 bits that is somehow figure out conversion. D3.color ordinal color scale. I forgot how to do this. Not gonna lie. So let me do a good practice, which is going to the code right here and just reading it up. As we can see, the ones I want is, I think it's mapping to 12 colors. Where is it? We can just do scheme category 10. Okay. And then for the colors, I'm going to do, instead of orange, D dot continent to color scale D dot home continent. Okay, and as we can see, we have different colors. Now, of course, we're gonna mess around. So this right here is basically making a new array where the where all of them are just home continents, right? Because we're returning only home continents, and we're taking the key, so we're only taking the possible home continents out there. So it's going to be like 8 of them, and we're going to map that to 10 colors. Then in here we can just apply that scale to a home continent to be able to evaluate a new Y output, right? The range, which is going to be one of the colors. Let me try something. Let me just play around with the colors. Is there no 12? There is no 12. Let me choose something cool. Maybe this one. This one's cool. I like that one. Yep, but that's it for this video. Again, thank you for watching. Make sure to subscribe if you liked it. But the most important lesson I believe you can take out is that we got to build the map and the circle differently, and the way we build the map is by taking the features from a GeoJSON array and then mapping each of the feature, running that through the D3.geo path with a specified projection, as we did right here, right? Running each of them through this. Then to make the circle, it's really important to remember that we also going to map the x and y values of that circle through the original projection. And if we ever want to change how the map wants to look, we can just change the projection up there to be able to totally change the looks. So thank you, and I'll see you next time.
Where you murdering the beat? Where you murdering the beat? Where you murdering the beat?